Okay, the last little section of trigonometry for AS Maths is knowing about trig identities. Now we have the following things that are true. Sine theta is identically equal to sine theta over cos theta. You'll notice those three lines on the equal sign there. That means that it's an identity, which means it works for all values of theta, not just one particular value. It works whatever theta is, you get that result. And the other one is cos squared theta plus sine squared theta is identically equal to 1. So for all values of theta, cos squared plus sine squared will always be 1. Now I'll show you where these come from. They're two very important results that you need to know for proving various different things in AS Maths. So if you think about a right angle triangle with sides of A, B and C and an angle of theta, then if you work out what tan, sine and cos theta are, you get those three results there of just, tan being opposite over adjacent, sine is opposite over hypotenuse, cos is adjacent over hypotenuse. Then consider sine theta over cos theta. So that would be the same as b over c divided by a over c, which of course is b over c times c over a. We can, if you're dividing by a fraction, you just multiply by its reciprocal. So the c's cancel out and you get b over a, which is the same as tan theta. So whatever a, b and c were, you will always get that result where sine over cos is equal to tan. Now think about sine squared plus cos squared of theta. That will be the same as b over c squared plus a over c squared. Multiply those out, put them over a common denominator, and then you're talking about b squared plus a squared on the top there. That by Pythagoras is the same as c squared because they're the two short sides squared and added together, so they make the square of the long side. So that's c squared over c squared, and whatever c is, that will always be equal to 1. So you get that result of sine squared theta plus cos squared theta equals 1. You don't ever need to reproduce these proofs, but it helps you to see where they've come from. All you have to know is how to use those identities that are at the top there in the red boxes. Okay, so examples of how to use these. We're going to simplify this. So start off with that top there. 1 minus cos squared theta equals sine squared theta, since we're using that result that sine squared plus cos squared equals 1, so it's just rearranging that. And then that's the same as thinking about sine over cos all squared, which is the same as tan theta squared, which we rewrite as tan squared theta. Now in reality, when you get used to doing these, you don't need those middle two steps. You can go straight from sine squared over cos squared equals tan squared. I just thought it would help you to see them. Okay, so example number 2. Eliminate theta from these equations. So if we're eliminating theta, we're wanting to connect x and y in some sort of equation that doesn't have a theta in it. So let's start by rearranging this to be sine theta equals x over 2, because we want to use this result. Sine squared plus cos squared makes 1, because that equation itself takes something that's in theta and replaces it with just a number, 1. If we can use that, then we can get rid of theta. So sine squared will be x over 2 squared, and cos equals 2y, so that's cos squared would give us then 2y squared, and that will all equal to 1. So multiply out those brackets and you get x squared over 4 plus 4y squared equals 1. And you should have spotted by now we've managed to eliminate the theta. We've replaced it with x's and y's instead, and we know that they're equal to 1. Now just one final little step. Usually we like to tidy that up so it doesn't have any fractions in it. So we'll multiply everything by 4 to get x squared plus 16y equals 4. Okay, example number 3. Angle A is obtuse and sine A equals 5/14 of root 3. Find the exact value of cos A. So for this one I'm going to use the sine squared plus cos squared equals 1 result, and since we're told about sine and we want to work out something about cos, and that one connects the two of them. So cos squared will then be 1 minus sine squared. I've just rearranged that since it's cos A that we're looking for. So that'll be 1 minus 5/14 root 3 all squared. So that's the sine A squared. So if we square that, you get 25 over 196 times by 3. That's just each of those components squared. And that gives us 121 over 196. Then cos A will be the square root of that, and we need to take the plus or minus root. Either one of those squared could have given us 121 over 196. So now we need to be able to decide whether it was the positive or negative square root that we're looking for as our answer. And that is we decide that from the clue where A is obtuse. So being obtuse, A is between 90 and 180. So we need to consider what happens to cos between 90 and 180 and whether that would give us a positive or negative result. So have a look at the graph. We're looking at that section between 90 and 180. Now in that section, that cos graph is always below the x-axis, which means that the cos values in that range are always negative. Therefore, our final answer needs to take the negative square root, so cos A will be minus 11/14. Okay, now this is a proof one. This is a kind of question that you haven't really come across before, and there is definitely a specific technique and strategy to doing these. First and most important rule is you do not work with both sides at the same time. You cannot use the fact that these are true to prove that it's true. You're trying to show that one side equals the other. You cannot work on both sides and move around between the sides like you would do if you were solving an equation. Okay, so you need to either start with the left-hand side or the right-hand side and work it through until it equals the other one. Now, occasionally, you do need to do it on both sides until you get to a middle point and show that they're equal to each other. But you don't ever work on them at the same time. You do each side separately. Okay, so let's do the left-hand side on this one, since that is the slightly more complicated looking side. That's usually your best bet for starting with, and you should be able to see that you've got more chance of doing something with the left hand side because you could combine that into a common denominator first of all. So left hand side, you always start by stating the side that you're working with. Now if we rewrite 1 over tan theta, well, tan theta would be sine over cos. So 1 over tan theta will be cos over sine, okay? And then put that over a common denominator of sine theta, and you get 1 minus cos theta on the top, which you will notice is the same as what we're looking for. So then your last thing is just to write equals right-hand side. Now you may have to start with the right-hand side and work it through until it equals the left-hand side, or you may do the left-hand side and get to a point where you just can't see where to go. So you start again on the right-hand side and you hope that you can meet it in the same place in the middle. You'll get more of an idea of these as you practice them.